Hello again. Good afternoon. So I will be giving presentation on behalf of my colleague Albert Lee, and he's from the Taiwan National Space Organization. And so we are building APRS-based PocketQube. So basically, APRS is like you take the different data, like could be GPS or could be weather data that you can uplink to the PocketQube, and then you can downlink to some other station, ground station. So it's kind of like basically this has been used for balloon systems, like weather balloon or climate. There are lots of students who does that. Put the APRS transceiver and then you launch it, and you get the you got to get the location as well as the temperature or humidity or whatever sensors you have. So this thing, there are lots of APRS transceiver launched using balloon. And now we are thinking about using the same transceiver concept in the satellite. So it's kind of like stored and forward concept. So you store it and move it to another location and downlink to the ground station. So the process is known as stored and forward. The satellite is moving, so it can give information like in context of Nepal. What we can do is like you constantly monitor the river. In Nepal we don't have sea, so you take the water level in the river, and then you transmit, and then it will downlink somewhere like in Kathmandu, and we can do constant monitoring of the water level. So you store and forward. So that's the concept of our APRS PocketQube. And basically, so this is how basic concept, the building block. You have UHF uplink, where you can transmit the signal, the information, like different data, like as I mentioned, water level, or it could be other weather information. Then you have APRS modem, MCU controller, data handling, and then downlink to the other station after next pass of the ground station. So stored and forward concept, and this uses AX.25 protocol. So this is more like digital communication, and yeah, so that's the basic concept. The transceiver we have, this is the transceiver which is operating like let's say roughly 5 volt, and at the frequency 144 megahertz with it. So this is the PCB board thing. You can buy this already for the balloon. You can connect them with the Raspberry Pi, and the size is a little bigger, so I'm not sure how. I mean, you can see the board size is already 5 by 5, so maybe they need to do the custom build. But this thing you can already buy and do the test with the balloon launch. And the data rate is here, AFK based, and 1200 bps. And then there is a more sensor spec, so it's kind of like a small cube. You can see here, this is the box, small cube. It consists of microcontroller already inside and different sensors. And then you can also like a small cube that you can plug and play, kind of, just connect multiple block of the cubes, and it can does, yeah, you can do different testing based on what you add on top of it. So basically, it has already the sensor board and also the power supply board. So these are the modules that you can buy, like different power module or computing module or sensor module. So this is from more sensor spec. So it's the concept to follow this. And this is the link posit. So the important thing would be like the link margin, still 10 dBi. And the power budget. So basically you have the controller from the mode sensor and the power module, which is also from the mode sensor, APRS receiver and transmitter. And yeah, roughly you have so total 1 watt. Yeah. I mean, yeah, this is just the number you can see. So all this concept, like why they are doing it, or the colleague from Taiwan, because this is the concept behind. So they are building 2.5 CubeSat, and the 0.5, the space is anyway you need to pay for it. And the idea is that they will build small PocketQube that fits in this 0.5 unit, and they can utilize this space. Otherwise, you are just paying for the space which you are not using. So they already have the CubeSat, and they would like to utilize this space, the remaining here. So they will divide them into 4 parts, and you have PocketQube on those places. So I think it will be a little smaller rather than the 50 mm size, because the deployer will not have enough space to put all real standard PocketQube. So I think if they are going to do it, I think it will be a little smaller than this standard PocketQube. So that's the driving key idea why they want to do it, and they are doing the APRS based PocketQube. Yeah. Thank you very much.